Welcome to This Explainer. Today, we're diving into one of the most phenomenal, almost cinematic chain reactions in all of human biology, the exact mechanisms of wound healing. But we aren't just going to look at the stages of healing. We are going to solve a fundamental mystery about how localized, invisible chemistry orchestrates a massive biological response.
Think about it. You cut your finger. It's a sudden, violent disruption to your tissue and your blood vessels.
Instantly, blood begins to clot. The body is already reacting in a matter of mere seconds.
And within minutes, an incredible microscopic cavalry of immune cells, literally millions of them, starts moving directly toward the site of the injury.
But here's the real question. How does your body know exactly where the damage happened? I mean, there's no tiny, conscious alarm in your brain shouting, "Hey, the wound is over here." Your cells don't have eyes. They don't possess conscious intelligence. So what is actually guiding all these cells to this precise microscopic location? Well, to understand this, we have to look at the local molecular signals acting as the guide.
Let's get into Section 1, the moment of injury. The cascade begins.
So, acute wounds heal in a highly orderly, overlapping timeline. It progresses through 4 distinct phases. Hemostasis happens in seconds. Inflammation takes over in hours. Proliferation spans days, and remodeling, well, that can take months. And these aren't isolated events. They bleed into one another seamlessly.
When a blood vessel is ruptured, it suddenly exposes things that are normally completely hidden from the bloodstream, specifically extravascular collagen, like type 1 collagen. The body doesn't need a conscious alarm because the physical damage itself exposes these structural proteins. That instantly kicks off a highly localized chain reaction.
Section 2. Platelets and the clot, stopping the bleed.
Now, platelets circulating in your blood don't consciously search for a wound. Instead, as blood spills out of the damaged vessel, those platelets physically bump into that newly exposed collagen. They detect it using specific cell surface receptors called integrins. And once they attach, they activate. They start releasing soluble mediators and glycoproteins that signal other platelets to become sticky and aggregate together into a plug. Finally, the coagulation system steps in, forming a fibrin web that traps the platelets and creates a sturdy matrix. Just like that, the bleeding stops.
This marks a really crucial shift in our timeline. Hemostasis is just the immediate physical patching of the wound. It's a rapid fix using a platelet plug and a fibrin web, but it's totally temporary. The inflammation and repair phases that follow have a completely different goal, removing devitalized or dead tissue and coordinating the long-term rebuilding of the area.
Which brings us to Section 3, the invisible chemical GPS, navigating the matrix.
As those platelets form that initial clot, they release a massive payload of chemical messengers. We're talking about growth factors, cytokines that regulate inflammation, and a very specific group of small regulatory proteins called chemokines. These are strictly localized triggers. The injured cells and platelets are essentially creating a highly concentrated molecular environment right at the very site of the damage.
And this creates what we can think of as an invisible chemical GPS trail. The biological term for this is chemotaxis, but I want to be absolutely clear here. This is just an analogy. Your cells are not literally using a GPS, nor are they consciously searching for anything. Chemotaxis is simply the movement of cells directed by a chemical concentration gradient. They are biologically programmed to move from areas of low chemical concentration to areas of high concentration, and that naturally leads them right into the center of the wound.
Section 4. Immune cells arrive. The cleanup crew.
Now, because these chemical gradients are highly concentrated right near the wound, the body's response stays incredibly focused. To actually reach the site, immune cells have to exit the highway of your bloodstream through a process called extravasation. First, white blood cells, leukocytes, weakly adhere to the blood vessel walls, the endothelium, and literally begin to roll along the surface, kind of like a car slowing down on the shoulder of a road. As they roll, chemoattractants from the wound activate them. They firmly adhere using those integrin receptors we mentioned earlier, and then, responding to the chemical gradient outside the vessel, they quite literally squeeze between the endothelial cells and migrate right into the damaged tissue.
The first responders on the scene are neutrophils. They arrive to respond to microbes and essentially eat bacteria and damaged material. After a couple of days, they undergo programmed cell death and pass the baton to tissue macrophages. Think of macrophages as the site managers. They continue the cleanup, sure, but more importantly, they release growth factors to help mediate the transition from the fiery inflammatory phase into the repair phase.
Let's look at Section 5, rebuilding and remodeling, constructing new tissue.
With the inflammation slowed down, the
the key builders finally arrive. Guided by signals from those macrophages, fibroblasts migrate in to deposit a brand new matrix of collagen. Endothelial cells begin restoring the blood supply, and cells like keratinocytes migrate right across the wound surface to rebuild the skin barrier.
But how does the body actually know it needs new blood vessels? This is fascinating. The damaged area naturally has low oxygen tension, or hypoxia. This low oxygen environment directly causes cells to stabilize a specific protein, which then stimulates the synthesis of vascular endothelial growth factor, or VEGF. That VEGF then causes nearby capillary endothelial cells to sprout and grow new blood vessels directly into the wound. It's called angiogenesis. The problem literally creates its own molecular solution.
You know, closing the wound isn't the end of the story. The early granulation tissue that forms is made of type 3 collagen, which is disorganized and relatively weak. During the final remodeling phase, which can literally take months, this is replaced by much stronger type 1 collagen. The fibers are reorganized and heavily cross-linked. Ultimately, this restores the tissue to a maximum of about 80% of its original strength. Healed tissue is truly amazing, but it's never quite as strong as tissue that has never been wounded.
Section 6. A localized molecular masterpiece, solving the mystery.
So going back to our very first question, how does your body know where you are injured? Well, the answer is, it doesn't need to consciously know. There is no central alarm system in your brain dispatching a fleet of cells with exact coordinates. Instead, it is a beautifully orchestrated, totally decentralized sequence of localized chemistry.
The crucial takeaway is summarized perfectly right here. The injury itself creates a local molecular environment. The cut exposes hidden collagen. That activates platelets. Those release chemical gradients, which change the behavior of nearby blood vessels, which in turn pull in immune cells and fibroblasts. Every single step is a blind yet perfectly calibrated reaction to the local chemistry immediately surrounding it.
It really changes how you look at yourself, doesn't it? You are a walking, breathing universe of localized chain reactions. Which leaves me with this thought for you. If our cells follow these chemical trails so flawlessly, without a single drop of conscious awareness, what other complex decisions in our bodies are actually just the result of brilliant, invisible chemistry? Thanks for joining me on this explainer, and I'll catch you on the next one.